everyone, my name is Alyssa, and today I'm going to be talking to you about tidal power and the advantages and disadvantages to harnessing this type of energy. Power from the tides is the oldest form of energy, dating back to around 800 AD. Originally, it was used to harvest and smash grains. Britain, France, and Spain also harnessed tidal energy as early as the 11th century. So what is tidal energy? Tidal energy is a form of hydropower that harnesses the energy of tides in order to convert it to electricity. It is the only type of energy that utilizes the orbital characteristics of the Earth-Moon system in order to produce electricity. So how do the tides work? Tide energy is a product of the Earth's rotation combined with the gravitational pull of the Moon. The Earth and the Moon are attracted to each other through gravity. The gravitational pull from the Moon causes the oceans to bulge out toward the Moon, creating high tides. The Earth is also pulled toward the Moon, but with less strength. This pulls the Earth away from the water on the far side of the Earth. I don't know if you can see this picture, but it's showing like if the Moon was here, it's pulling the water towards it, and then it's also pulling the Earth this way, and the water stays where it is. So there's a high tide on the far side and on the close side. Since the Earth spins and the Moon rotates around the Earth, we experience 2 tide cycles per day. So how do we harness this tidal energy? As tides rise and fall, a massive amount of water moves toward and away from shore. Turbines placed in water harness this energy by spinning as water passes by and can convert this energy into electricity in 2 ways. Using the change in height of tides, which would be potential energy, or using the flow of water, which is kinetic energy. Currently, there are 3 main methods of tidal power plants: tidal streams, tidal barrages, and tidal lagoons. The tidal stream method uses moving water to power turbines that are connected to electrical generators. These turbines are strategically placed where water is forced to flow through a narrow channel or around headlands because tidal currents are the strongest here. This method is easily removable and can start as a small energy plant and grow to a large plant at any time. This feature facilitates lower costs initially compared to barrages. So this picture just shows all the different types of turbines that can be used in a tidal stream method. So the one up here is called a sea snake, and I didn't really find too much information on that type of turbine. But basically it uses the waves to move a hydraulic ram that then generates electricity that way. 2 is this, sort of looks like a fan or like a wind turbine. These are the most common ones that I found, and basically they just let water go past when the tide is coming in and back when the tide is going out, and it makes them turn and then generates electricity. 3 is just more like a fan, just a different sort of structure to that one, but same idea. Then there's a tidal barrage method that uses a dam that spans the entire width of a tidal estuary with a free-flowing connection to the ocean that operates by utilizing the water difference of high to low tides. The barrage gates are left open while the tide is rising and close at high tide. The water can only escape through openings that contain turbines connected to electrical generators. This method has significant environmental impact because the land is disrupted in the tidal range and organism movements are affected. Barrages require more initial investment than the other 2 methods because there are more construction and machines initially required, and plants also require supervision at all times. So this picture just sort of shows you how a dam works. It's similar to hydroelectric dams, but when the tide is coming in, the water goes through the turbine and generates electricity, and there's also gates, which you can't see here, and then they close, and then when the tide goes out, the water can only go through the turbine as well, so it generates more electricity. These turbines typically move a little bit faster than the tidal stream turbines, so aquatic life is a little bit more endangered there. This is just an aerial view of the station. It's quite large, but they have roads that go across, so it doesn't really hinder much for human life, mostly just aquatic life. So the third method is the tidal lagoon method. This method is essentially the same as the tidal barrage method, but the dam doesn't have to extend across the entire estuary. This reduces costs and environmental impacts. Dams can be constructed with natural materials such as rock, making them invisible during high tide, and they look similar to a seawall at low tide, so it's not very aesthetically terrible. Since sharks can't penetrate the lagoon, smaller fish would probably thrive and birds would flock to the area. However, energy output is believed to be low. This type of method hasn't really been used that much yet, so there wasn't much information on it. So the characteristics that I've listed sort of are just what scientists believe will happen. And this is a picture of a tidal lagoon. So basically it's like a lagoon inside the barricade, and then they've got turbines throughout the wall, and then as the tides rise and fall, they generate electricity. So what are the advantages to this type of energy resource? So once initial construction costs are surpassed, it's very inexpensive to continue harnessing energy. Tidal streams have minimal maintenance and personnel, and as technology in this field evolves, initial costs will decrease, as with pretty much anything. Tidal energy is renewable, predictable, and sustainable. Harnessing the flow of water in predictable tidal cycles does not deplete the Moon-Earth gravitational pull. It's always going to be there. It's been there as long as the Earth has been around. So as long as the Moon continues to orbit the Earth, this resource is inexhaustible. Potential energy production is high. In 2013, the worldwide potential for tidal energy was estimated to be about 700 terawatts per year. After construction, tidal power plants don't emit any greenhouse gases and don't take up much space. They may also actually decrease CO2 emissions by facilitating photosynthetic organism growth in lagoons. Tidal turbines are effective at low speeds because water is dense. It's approximately 800 times more dense than air, so they don't have to spin very fast to generate electricity like a wind turbine would. Tidal power plants can be long-lived, reducing consumer costs for electricity. For example, the Lawrence plant was opened in 1966 and is still generating electricity today. Large-scale harnessing plants could lead to a reduction of imported fuels, improving energy security for countries capable of constructing plants. Alright, so now that we've gone through advantages, there are a couple of disadvantages which I've just slightly touched on already. Research suggests that around 20 areas in the world would work to harness tidal energy. Only China, France, England, Canada, and Russia have a large potential for this type of energy production. Environmental effects. Barrages rely on manipulating ocean levels and potentially have effects similar to hydroelectric dams. Tidal plants can be detrimental to marine life by disrupting the movements and migration of fish and other ocean life. If big animals can't migrate through an area that they normally do, then that's going to affect small life populations and plant life populations. As well, the turbines can kill organisms, even though they typically don't have to move very fast to generate electricity. It all depends on the flow of water and how fast it is. So if there's a fast flow, then the turbines will be moving faster, and fish and other life can get caught and killed by them. An example of aquatic changes is at the Rance River plant, the barrage has led to increased levels of silt that suffocate native aquatic plants. As well, a flatfish has become extinct that normally flourished in the area, and cuttlefish now thrive there. Harnessing tidal power is such a new technology that methods are still expensive. One study suggested that ocean power generation could cost more than $400 per megawatt hour compared to other renewable energy resources, which are around $150 per megawatt hour. With technological advancements and larger scale plants, it is expected that tidal energy could be commercially profitable by 2020. And finally, electricity can only be produced during tidal surges, which actually last about 10 hours a day. But therefore, energy storage needs to accompany tidal plants.